So, hello everyone. I hope you can hear me. My name is Daniel Orenke. I'm head of programs at Students Against Poverty Africa, and I'm also coordinating this program, the AMR Ambassadors Program, for young people in Africa, together with Anastasia Nabionga, who is also in the call today. So today we are privileged to have two really guests with us, people who really inspire me a lot. I've worked with them before on a paper that we did that was in earlier this year, and it's really great, to have them today talking to us. I'll stop sharing my video in case it might maybe affect my bandwidth at this point, but that's me. I hope you've seen me. Thanks so much. So today we are privileged to host Maarten Van Dongen and Heather Graz, and I'm really glad because I think we've engaged so much with them. I think Maarten, this is maybe that year now. We've been engaging a lot, and also I came also to meet Heather as we're also working on some of the papers that were led by AMR Insights. So I'd just like to introduce our guest speakers for the day, and I'll start with Dr. Maarten Van Dongen. And Dr. Maarten is originally a molecular and medical microbiologist. And after his PhD in biochemistry at the University of Amsterdam in Netherlands, he worked for the international pharma and biopharma industry in the Netherlands, Switzerland, Finland, and Belgium. And later he advised Netherlands in international public health and private organizations in the domain of life sciences. As an advisor, Maarten was increasingly asked to lead large projects in the field of AMR. And in 2015, he was asked by the Dutch Ministry of Health, Welfare and Sports to design a national collaborative structure for the development of new antibiotics. In 2016, together with 12 Dutch organizations, he explored the potential to set up a new global information platform on AMR. And he founded the AMR Insights in 2017 and decided to focus his professional activities on combating the global threat of AMR. So AMR Insights, as we'll maybe hear from Maarten and Heather, informs, educates, and connects professionals with the aim to curb antimicrobial resistance. AMR Insights has the ambition to develop to a global information platform and competence center on antimicrobial resistance. And Maarten is committed to eliminating AMR because it does not accept that a million of innocent citizen people need to die as a result of drug-resistant bacteria and other microorganisms. So that's Maarten. And our other guest speaker for today is Heather Graz. And Heather is a communications professional with a blend of experience in patient-focused healthcare settings and private life science in research and development organizations. And she has a particular interest in managing the effects of AMR and experience in being part of teams that create conditions for people to remain healthy, happy, and economically active. So for the past decade, she has worked together with biotechnology, SMEs, and academic institutions who are developing and commercializing diagnostic devices and novel antimicrobial therapeutic interventions. Over this time, her projects have included helping startups and scale-up biotechnology companies to raise their public profile, develop their brand, understand potential customer needs and requirements, creating relationships with business partners, and raising funds. So Heather completed her undergraduate and master's degrees in South Africa. She also did an MBA in Exeter, UK, and is currently completing an interdisciplinary PhD in computing and psychology at the University of Dundee, that is in Scotland. So thanks so much, and welcome so much, Maarten and Heather. Really glad to meet today in this forum and to get to hear from you. Thank you so much, and over to you. Thank you and welcome. Thank you to our guests. And welcome to the session. Over to you.
Thank you very much, Daniel. Can you hear me and can you see this first slide?
Yes, we can hear you and we can see the slide.
You see the slide, the first one? Okay.
Yes, yes.
Daniel, once again, thank you very much for inviting me to this important program. It is an honor for me to contribute to this activity. I also want to compliment you, but also your other co-founders with setting up SAS Africa, Students Against Superbugs Africa. I think it is really a great initiative. You have done a great job, and it's even greater that you're also organizing events and knowing that students are also busy with their own studies. So once again, my compliments for that. I'm most happy to tell you something about well, AMR in the context of data technology, data sciences. Please see this as an informal presentation. If you have any questions, then happy to answer questions. Happy to you may even interrupt me if you want. I will start with a sort of a general introduction about AMR and then gradually zoom in on the role of data technologies to curb AMR. And then later on, Heather Graz will take it over, starting from a special publication we have drafted and submitted earlier this year, where also Daniel was one of the co-authors. So I think it's a very good coincidence. Okay, I'll just go briefly through my slides. A few words about AMR Insights. AMR Insights, what Daniel said, was started 6 years ago. We focus on informing, educating, and connecting professionals in the domain of antimicrobial resistance, newsletters, masterclasses, webinars, symposia, missions. We have set up a large network of ambassadors in 60 countries with now 480 ambassadors. And these ambassadors initiate projects, carry out projects, come to new publications. We're also in the process of building databases with expertise and technologies, and we are open to many different partnerships where large organizations can team up with AMR Insights to combat AMR. AMR starts, I always start with this first slide. This is a publication in The Lancet that has appeared in February of this year. And actually this is the publication of the Graham project. This project showed that in 2019, we, at a global level, we were faced with approximately 5 million people dying from AMR, from antimicrobial resistance. So this paper was actually a shock that so many people could die from antimicrobial resistance. And knowing that AMR is only escalating, we have to realize that that the number of casualties is really threatening, is really alarming. Talking about AMR, how does AMR arise? We all use antibiotics to the end. I hope not too much, but we all may use antibiotics. It's used for livestock treatment. It's used for the treatment of animals. It's also sometimes disposed inappropriately. It's used in aquaculture. It is used for human healthcare, of course. Also, it is sometimes discharged by manufacturing antibiotics. And ultimately, we as human beings suffer from AMR because we may die or our diseases may not be cured appropriately. And antimicrobial resistance is a very complex and abstract problem. We do have a lack of understanding. It is a distant problem. And when you compare this to COVID, to Corona, then you see on the right-hand side the website that almost showed real time how many people were dying from AMR, from COVID. And with AMR, we do not have such data. And here I already mentioned the word data, because data are, the clue to success. And knowing data, using data, working with data, and that will come back later on. AMR is complex, so I always briefly explain AMR in 10 statements. And first of all, AMR is a global threat, taking place everywhere in the world. It can affect anybody, everywhere at any time. Young people, healthy people, sick people. And there's a sort of a continuous movement of microorganisms, plasmids, but also antimicrobials around the globe. And this movement also, this spreading mix also at AMR is continuously spreading around the globe. So a novel resistant bacteria appearing in China may be available or may be demonstrated in Africa after 3 weeks, and 2 weeks later in Europe, and maybe 1 week later in the United States or in other directions. So it is constantly spreading around the globe. The second thing is that AMR is a hidden threat. It's not always diagnosed, it's not always documented, and not always are the data being collected. As an example, I always say, if someone dies because he has a resistant bacteria causing tuberculosis, then in fact he or she is dying because the antibiotics do not work to curb this specific, this resistant antibiotic tuberculosis bacterium. But the statistics will only talk about tuberculosis. No one will write down because this patient has died because he had a resistant bacteria causing tuberculosis. No, it is always said, well, this patient has died because of tuberculosis. So in fact, we do also lack a lot of data. Then AMR is applicable to all microorganisms. It's not only about bacteria and antibiotics, it's also about viruses, yeasts, fungi, parasites. Think of malaria. All these microorganisms can become resistant to their antimicrobial compounds. And the bacteria are by far the most prominent, and the most people die from resistant bacteria. Overall, there's a correlation between the use of antibiotics in a country and the amount of resistant bacteria. And this is a graph from the Review on Antibiotic Resistance by Jim O'Neill from 2016. And here you can see that, as an example, countries such as France, where there is a relatively high use of antibiotics, that there are many more resistant bacteria than compared, for instance, to the Netherlands, where there is a very strict use of antibiotics. At the same time, banning antibiotics is not the solution, obviously. And this very simple graph shows you that, well, if you use many antibiotics and many antimicrobial compounds, then you do get resistant bacteria. But of course, many people dying from that because bacteria become resistant. But at the same time, if you would ban antibiotics and go to very low amount, then of course infectious diseases may come up again, and then people may die from these infectious diseases. So the challenge we are facing is that we need to come to a very prudent, rational use of antibiotics. And also data technologies, as I will tell you later on, can be instrumental there. AMR at the global scale is escalating. That is something we have to realize. At the same time, we do need novel antibiotics, to which bacteria are not yet resistant, and the pipeline is very empty. So the last decades, we have hardly seen any new antibiotics appearing on the market, and that is also, well, of course, very, very worrisome. And also to come to more novel antibiotics, we can use data technologies, as I will show later on. So I'm already now showing that data technologies play a role in all these different aspects of antibiotics, and I will make that more concrete later on. AMR has an uncontrollable dynamics. It is just appearing and spreading and multiplying in an uncontrollable way. And I will only show this first slide, this video, where you can see how rapidly bacteria may grow.
By doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
So on average, a bacterium takes 20 minutes to multiply, from 1 to 2 to 4 to 8 to 16. And as you can see, this can go very quickly and give rise to many bacteria and also give rise to many resistant bacteria. The second and the third video would take too much time, but anyhow, what I want to say is that within a matter of days, bacteria can become resistant to extremely high levels of antibiotics. And the third video shows you that resistant bacteria can also transmit their resistance genes to other bacteria in their surrounding. So this whole makes that AMR has an uncontrollable dynamic. AMR also makes medical interventions impossible. For instance, cesarean sections, chemotherapy, but also stem cell therapy. And because in these cases, in these interventions, antibiotics are used as a preventive measure. And if bacteria are resistant, then these preventive measures simply do not work anymore, and these interventions become impossible. Another important point is to realize is that AMR is observed with all antibiotics, all commercially available antibiotics. So as of the very first antibiotics, such as penicillin, as well as the later on appearing on the market, bacteria become resistant. And sometimes resistant bacteria are noticed, well, just a few weeks after an antibiotic has been introduced. sometimes after a few months, sometimes after a few years, but in all cases, after some time, resistant bacteria appear. And it is, well, most likely, because bacteria are extremely creative and have many tools available, it is most likely that also for the future antibiotics that may appear on the market, that also bacteria will or can become resistant against these novel antibiotics. So this is something we should realize when talking about solutions to curb AMR. This is my last statement. There is not one single solution to AMR. In that respect, it is comparable to the climate change problem, because there are, in fact, many different solutions, key strategies to curb AMR possible, but also needed. And only by combining these key strategies, we may be able to diminish AMR at a global scale. Talking about these key strategies, all these key strategies also make use of data technologies. But let me first tell you something about these key strategies. And because what I said, there are different ways to combat AMR. And these all start from what is called the One Health concept. That's important to mention also in this lecture. It's not only about the hospitals and medical doctors. AMR is a problem in society. So we are dealing with the human health sector, the animal health sector, the agri-food sector, the dairy sector, the meat sector, the environmental sector. And as a result, the key strategies to curb AMR also arise from all these different sectors. And let me then briefly introduce the different key strategies. And the first one is, of course, the prevention of infectious diseases in human healthcare, but also in animal healthcare. So prevention by means of vaccination, hygiene, the WASH concept. The better we can prevent infectious diseases, the less antibiotics we need, and also the less resistant bacteria can arise. The second thing is antibiotic stewardship, which is also applicable to human healthcare and animal healthcare. In fact, antibiotic stewardship says that we must be very careful when prescribing antibiotics. And prescribing antibiotics should only be done on the basis of proper diagnosis in human and in animal healthcare. The third one is the reduction of antimicrobials in wastewater. And especially manufacturers may discharge antibiotics in their wastewater, but also hospitals, nursing homes. And it's important to be able to measure antibiotics in wastewater and also to remove these antibiotics from wastewater, but also to measure resistant bacteria in wastewater and in surface water and remove these from the waters. Then there is, of course, we do need novel diagnostics, better diagnostics, preferably rapid diagnostics, affordable diagnostics, point of care. Then we also do need, what I said before, novel antimicrobials and novel antibiotics and other antimicrobial products, and for the different diseases. And we also do need alternative antimicrobial strategies, such as CRISPR-Cas, phage therapy, nanomaterials. And it will not surprise you that data technologies are in fact applicable to all these different key strategies to curb AMR. They all can play a role, they all should play a role. And I will come back to that later. As a result, we AMR Insights focuses also on different focal areas because our starting point is professionals. People need to assume their responsibilities when it comes to curbing AMR. And so we focus on medical doctors in hospitals and on nurses and on healthcare practitioners. We focus on veterinarians, on animal farmers. We focus on people working in the food sector. We focus on people working in NGOs. We focus on innovators in universities and startup companies and pharma companies, diagnostics companies. We focus on people involved in the environment. We focus also on students, as Daniel knows. We are active in several student initiatives. And last but not least, we also focus on citizens. And citizens, we are all also citizens. We can be patient, but also anyhow we are citizens. And also citizens have a role to play when it comes to curbing AMR. And it will not surprise you that data technologies can be applied to all these different activities and by all these people. As an example, the pharma industry can use data technologies to come to better antibiotics. Data technologies can be used in the environments for surveillance. So my point is, and also coming back to citizens, the spreading of resistance as an example. So in fact, data technologies have the potential to be involved, to be used by all key strategies, but also to be used by all the target groups mentioned here. So there's every reason to use data technologies to the extent possible. And then zooming in some more detail about on data and data technologies, it's often said this is the age of the data, and a lot is going on in the data world. And of course, we do get next generation internets, the faster connections. There's an exploding volumes of data, as you can see in the graphs. There are increasingly also real-time data available. The databases, the processing time is being reduced. We do get an increasing amount of mobile applications and handheld devices, apps to follow, monitor, check, control. But there are also increasing concerns about the ethics and the access to data, the privacy aspects. And so we are in a very dynamic period. And at the same time, there's also the developments in the technology itself, the quantum computers, the processing time is being reduced, the memory space is being increased. So we are increasingly better able to process and to store data and to come to novel insights. But it's said that it's also becoming more and more complex. So there's every reason also to educate people about data technologies, to explain data technologies, to teach on data technologies to high school and to primary school students, high school students, and also to university students, and not only medical students and veterinary students, but also other students who are not. Then, talking about data technologies, there's also a lot of misconfusion or misunderstanding of data technologies. But in fact, we should talk about computer science and about data science. And data science is in fact the combination of artificial intelligence, machine learning, and deep learning. And there are more definitions. And it's important also to have a little bit of a clue what these definitions in fact hold. And then I start with computer science, which is sort of an overall definition, is the study of the processes that interact with data, and represented as data in the forms of programs. And computer science enables the use of algorithms to manipulate, store, and communicate digital information. Then we have artificial intelligence. I think that's what is heard mostly, AI, artificial intelligence. And that is intelligence demonstrated by machines that mimic cognitive functions, such as learning and problem solving. Then we have, in some more detail, machine learning. It's a category of AI, and machine learning is a study of algorithms and statistical models that computer systems use in order to perform a specific task. And machine learning algorithms, they build a mathematical model based on sample data to make predictions. This is also new predictions that you start learning from available data. For instance, when you come to new antibiotics, and that you also start making predictions based on data when you compare the new data with existing data. Then we come to deep learning, and that's a part of machine learning method based on artificial neural networks. And this is applied, for instance, to speech recognition, but also drug design and image analysis. And then we have another category that is data science, and that is a multidisciplinary field that uses scientific methods process algorithms and systems to extract knowledge and insights from structured and unstructured data. And data science is the same concept as what is called data mining and big data. And well, I didn't want to overwhelm you, but anyhow, I think it's important that you realize that there are different activities when you talk about data technologies. Because of the relevance of data technologies, we already 4 or 5 years ago started to initiate to set up international matchmaking symposia with the acronym ADTCA, and this means advancing data technologies to corner AMRs. The whole reason to organize these international matchmaking symposia is to boost the use of data technologies to curb AMR, but also to combine novel insights, to connect people, to initiate novel projects on data technologies, and also to boost innovation and international collaboration. And we will certainly organize this event again in June of this year. And if you subscribe to our newsletter, then you will automatically also be informed about the dates of these events, and then you can also join these online events. I'm coming to an end of my presentation. I think I have 1 or 2 slides. This is now an important slide, and this is what I said a few times before. On the left-hand side, you see the 5 different ways to curb antimicrobial resistance: prevention, stewardship, diagnostics, antimicrobials, antibiotics reduction in water. And my starting point is that in fact all these different data technologies can be applied in a different ways to curb AMR. So we come to already now in this overview to something like 4 times 5 is 20 different applications. And as an example, you can use AI when you talk about prevention of diseases. You can use machine learning when you come to novel diagnostics. You can make use of deep learning when you come to novel antibiotics, and so on. Not all applications may be as feasible and commercially attractive, but in principle, there are many applications. So it is up to us to explore opportunities and to join forces, but also to come to the proper standards, to the proper ways to exchange information, and the proper ways to communicate with each other, and that we build databases that can communicate with each other, that we use similar artificial intelligence tools or machine learning tools, because then we can also come to a synergy, then we can combine data and so on. So that was also one of the reasons to organize that event, Advancing Data Technologies to Corner AMR. It is even more complex than what I have shown in this slide, because we're also dealing with the value chain. And the value chain is in fact nothing more than when you come to a novel idea, you start with research in academia, you come maybe to some development activities, maybe a startup company, then you come to registration, validation, and maybe a bigger company then acquires a small company, and ultimately you come to the marketing and to the commercialization of a new idea, and new diagnostics, a new antibiotic. And the interesting thing is that also in the different steps of the value chain, these different data technologies can be used. So as an example, artificial intelligence can be used in the research for novel antibiotics. But also, for instance, artificial intelligence can be used to monitor the usage of antibiotics on the market. So keep in mind that the value chain makes it even more segmented and provides novel opportunities. Then I also want to say that we are dealing with different types of data. Of course, we have the omics data, proteomics, genomics data. We have surveillance data, resistance data, global, regional, national, in human health, in animal health. But we also have usage data, for instance, the use of antibiotics. And well, I think I made my point already. There are so many different types of data that, again, there's every reason to structure the process of the uses of data to come to proper agreements on what is being used and how it's being used, and to come to also alignment of the different technologies. And that was also the reason, and now I'm coming to my last slide, to well, collect a number of people and to come to a new publication with the name Applying Data Technologies to Combat AMR, Status, Challenges, and Opportunities on the Way Forward. And this was, in fact, this paper was drafted by two first authors, Leonid Chilevich and Elita Yunakaite, and with a whole team of interested professionals that had contributed to this event, ATCA, including myself and also the next speaker, Heather Graz. And she will now zoom in on this paper to tell you more about, well, this way forward. Last but not least, I want to thank Danielle, but also SES Africa for providing the opportunity. And I'm most happy to answer any questions. Let me know if you have any questions, but also feel free to send me emails later on and or to submit to the AMR Insights newsletter. Thank you very much. I will now stop sharing.
Thank you very much, Maarten, for really that wonderful presentation. I appreciate, and I'll just share the website for AMR Insights in the group so that at least maybe so AMR Insights, if you want to become an ambassador, I think it's very easy. You'll just see the process in the website. So that it's my hope that all of us who are in the program will then transition to to the ambassadors network. So thanks so much. And at this point, we'll hand it over to Heather. Over to you. Thank you.
Let me just unmute myself. All right, now the thing is, can you all see my screen that I'm sharing?
Yes, nice visit.
Awesome. That is fantastic. So I'm just going to minimize that. I'm just trying to make sure I can actually read what I've written on the screen. Okay, so thank you so much, Maarten, for setting the foundation. I mean, laying that foundation. That's perfect for what I wanted to say. And thank you, Daniel and SAS Africa, for the invitation to join you all today. To share some of the highlights of the paper that we put together and that was published in July this year. So in the next half an hour or so, I am going to share some of the insights that we found when we did the literature review for our paper. I'm also going to give you a sneak peek of a second paper that we've managed to pull together that arose out of that first paper. And then I'm happy to take any questions. Yeah, so I mean, yeah, if you want to ask anything, please feel free to do so. What I will say up front is I am a science communicator by training. I am not a scientist by qualification. So please, if any of you do have technical questions, I will try and answer them to the best of my ability, but I am more than happy to find out the answer for you and get back to you. But yeah, certainly I've worked with some fantastic scientists for the last 10 years. And I have absorbed a load of AMR related science, but I am still only an honorary scientist in that regard. So if there are questions that I can't answer, I'll find out for you. Oops, and now I'm just wondering why I can't move my slide on. That's why. There we go. So the paper that we've been talking about, I feel was a case of the right idea at the right time. This whole idea of the idea was to have a tool that we could use to prompt action rather than just words. There've been lots of discussion about AMR and what it is and how we're going to manage it. But a sense of frustration, I'm talking now kind of at ADTCA last year, 2021, that there was not that much action happening, and that we really wanted something that we could use to prompt action to take place. And this was Maarten's sincere desire, and presented this to us at ADTCA last year on the 24th of June. And at the meeting, he said to us, anybody who would like to be involved in putting something together that we can use with high impact, please feel free. And so this was an idea, I think, that kind of fitted in at the time with some of the concepts that were quite big, that were starting to get more prominence at the time. So as Maarten said earlier on, the One Health approach by the WHO. So the thing about AMR, I guess, is that it's a global public health challenge, and it fits particularly well with the One Health approach, because we are never going to be able to address it properly if we don't address each of the sectors that is maintaining it and that it impacts on. So animal health, human health, environmental health, we've got to take all of those into account. And so One Health, it was our starting point. The other thing that at the time was our thinking was that, why data and why data technology? Well, because as Maarten said earlier, data is quite an issue in AMR. And often it's not because we don't have data, because there's a lot of data out there in AMR, but the data doesn't talk to each other. So we can't really do anything with the data that you have across various places. You can't add it all together and increase the volume and therefore generate more insights out of it, because the computer systems don't talk to each other. Or there's data and we just can't access the patterns that is in that data, so that's not helping us to create diagnostics, create further treatments. But the flip side of that is obviously that data technology is improving really rapidly, as Maarten said. And so we do now have access to quantum computing and other such technologies to much bigger number crunching power and scalable data management possibilities in artificial intelligence, machine learning, data analytics, and mathematical and statistical modeling. And so that was why we went for putting something together which would be able to manage data using data technology. Now, I do just need to let you know that why we only picked bacterial infections for the purposes of this study was because, we're completely cognizant that viruses and parasites and protozoans and fungi and yeasts can be just as resistant. But if we wanted to get a document that people would be happy to read because it wasn't too huge and it didn't look too frightening to look at, we thought, well, let's just pick one of those. And that's why we went with bacteria. The same process could just as well be used for any of the other microbes. And it would be great if somebody did want to do that in the future and see how is data technology being used with other microbes. So I'm just going to move on. And so it came to be that in around about September last year, a number of people met over Zoom, and there was a group of experts and people with interest in AMR from across the globe who sat down to put ideas onto paper that could be that were then published in July this year. So we had people from Europe, from Africa, from North America, from Southeast Asia, from Australia, people representing research institutions from biotechnology and pharmacy, industries, independent commissions, network-based organizations, public health and infectious disease organizations, and then people with an interest in veterinary, pharmacy, biotech, diagnostic sectors. So a fabulous group of people who could just give really diverse insights. And at this point, I do just want to say thank you to Leonard Chindelovich for letting me use some of the content of his slides that he first presented earlier this year in April at the Wellcome Trust Antimicrobial Resistance, Genomes, Big Data and Emerging Technologies conference. So what did we do? Well, we did a literature review, quite a large literature review. We looked at big data technologies and AMR. We looked, as Maarten said, at the 5 domains of surveillance, prevention, diagnosis, treatment, and implementation, because without implementation, without putting things into practice, we're not going to have anything to work with anyway. For our purposes, what we looked at in terms of how we defined AI was those computational processes that, whether you're looking at something general or specific, uses algorithms to crunch the numbers and give you and analyze data. Now, part of that AI might have been where data can, where patterns can be extracted and data inferences made without explicit specification from a person. And so that was counted as machine learning. And when we needed human expertise to explicitly say, we're going to be looking at this angle versus that angle, that then became statistical or mathematical modeling. And so what we found when we looked at the literature is there were a number of reviews. We weren't the only one. Most of those reviews only looked at one or more of the 5 modalities, so the surveillance, prevention, diagnosis, treatment, or implementation. None of them looked at all 5. And so that we felt was what we could bring to the party, that we could pull everything together into a useful composite whole. And as Maarten said, this was our paper on the 11th of July. It went up on ARXIV. And really what we wanted to come out of it was for people to see concrete actions that they could take to integrate the data technologies that are currently available, as Maarten explained, into healthcare and public health, and to focus on all countries, so high income, low income, and middle income countries, not just one or the other, because this is a global problem. So I'm going to just walk you through some of our findings in the next few slides. And we're going to start with surveillance. Okay, so the data technology findings, studies that we looked at, which looked at surveillance, had one of three outcomes. Now, the first one was they wanted to track antimicrobial prescribing patterns and resistance trends. And the information you want to look at on this slide is the bigger left-hand table. I am aware it is quite small writing, so I do apologize for that. I don't expect you to necessarily be able to read it that easily. If you would like to, if you do have any questions or you would like to see a bigger version, please do contact me. I'm going to highlight the key points out of that though for you. So in terms of surveillance programs that are out there, there was a study done in 2020, and I've got the DOI at the bottom of the slide there for you by Diallo et al. And they did a beautiful job of identifying 71 different surveillance platforms, which are fairly current. So we didn't go into a huge amount of detail in that. So their platforms, 90% of them are at national level. 10% or 9.9% at multinational level. 72% of those platforms that they found relate to Europe and the Americas, which means that 28% is for the rest of the world, and 75% of them relate to humans, which means 25% of those surveillance platforms relate to animals and environment. So, you know, it's comprehensive, but it shows where the gaps are in terms of surveillance. So if one looks at the table, what we looked at was how many surveillance platforms are looking at AMU, which is antimicrobial use, AMR patterns, how many are using genetics, where are they in the world, and the scope. So are they looking at humans, are they looking at environment, are they looking at animals? And so we can see that there are some ticks there in antimicrobial use and antimicrobial resistance. Some of them are looking at genetics. If we look at the scale, the vast majority are North America and Europe. And if you look down the final column, a lot of them are only looking at one part of the One Health concept. So they're either looking at humans, or they're looking only at animals or environment, or if you're lucky, two, animals and humans. But very few of them are looking, in fact, only one of them is looking at all three. And so what that's telling us is that most of the surveillance platforms out there that use data technology are not using a One Health approach yet. And so that gives a particular direction that one could look at in terms of handling AMR surveillance. So that was tracking antimicrobial prescribing and resistance trends. The next outcome that people looked at where they used data technology was defining genetic profiles for bacteria. And what you need to look at here is the small table on the right-hand side. So what that is showing us is there are a small amount of publicly available databases which document resistance mechanisms on the basis of genetic profiles which have been identified, but that's just the bacteria that we know about. That's not those which we don't know about. So at this point, this is where machine learning comes in, because it does have potential to show us new resistance mechanisms in bacteria, new MOAs, mechanisms of action, using whole genome sequencing. And so this is something which certainly could be looked at in the future. It's not there yet, but could be looked at in the future. And then finally, the last outcome that people looked at using data technology was looking at how well they could predict trends in AMR and use that for developing new interventions. So that this isn't really, there's a lot of room to go. There's a lot of space for improvement here. What would be fabulous is to be able to get some long-term antimicrobial use data and link that with the genetic data and see what interventions work with which bacteria. Currently, there's only information really on human infections, not much on animal or environmental. And so some people have done some mathematical modeling. Interesting to see where the machine learning side of things takes that. So it might not look like such a positive stance, but there are positives. There are now resources available to track use of antimicrobials and resistance trends. There are databases, and some of these databases are including genomic determinants. Problem is, those databases don't always talk to each other. We can't access some of the information that comes out of them because they're in PDF format. Metadata, so that data about the data, in other words, where did the samples come from? Who was your patient? Who were your patients that were tested? So the surrounding data isn't necessarily in a format that machines can read, and then obviously matching data, genotypic and phenotypic data is sometimes a little bit difficult, but we're moving in that direction. So moving on to prevention, that's the second of the domains. So this is a sector that data technology is fairly, is in the early stages of. So there have been some AI and machine learning applications looking at a couple of large-scale databases or data sets for things like carbapenem resistance in bacteria, or in cefiderocol, which is an antibiotic which is used for complicated UTIs and respiratory pneumonia, ventilator-associated pneumonias in hospitals. So that kind of stuff is starting, but it's still quite early stage. Where we are finding data technology being used is in more in infection control and prevention, particularly in hand hygiene, and seeing how people comply with hand hygiene programs, and in food safety. So in detecting where an outbreak might be, and in where its sources. There's also a role for prevention in designing distribution for vaccines, for example. Maarten spoke about vaccines as a preventative measure. Machine learning is fantastic in this, in terms of just being able to handle loads of complex information and difficult to handle data if you didn't have a machine to do the scenario planning. And then finally, identifying populations who are at the highest risk for AMR infection. So being able to take a very large volume of electronic health records, extract relevant information, and being able to predict who is going to likely get infection. So there has been some work done on sepsis, on bloodstream infections, on hospital-acquired infections, and C. diff as a gastrointestinal infection. All right, so then moving on to diagnosis, this is the third modality. So the thing about, as a lot of you will know, is that traditional diagnosis for bacterial infections relies on laboratory testing of cultures. As I say, it's in the lab, it's not at point of care. You need equipment which is expensive or not available. You need staff with the relevant training, and it therefore becomes really difficult to access this kind of diagnostic. And it takes 2 or 3 days to get a single result, which is not really helpful for antimicrobial stewardship or antibiotic stewardship. There are some diagnostics being developed. In 2020, for example, there were about in excess of 220 new diagnostics developed in the US and Europe. However, that was for all illnesses, not just bacteria. In fact, only 4 of them could be used for microbiology, which goes to show we don't have a lot of new diagnostics coming through in the pipeline yet, which are ready to be put forward for approval. So the information that we found in our review related to genomic tools and non-genomic tools. We're not, again, apologies for the little, the small writing. Please do ask if you have any questions. The key point that's coming out of this slide, which is the genomic tools, is that there are, if you look at the 3 little columns down in the middle, so there's the ability to detect an infection, to the ability to identify what is causing that infection organism-wise, and the ability to get an susceptibility profile, antimicrobial susceptibility profile. So very few can do all 3. Most of what we've got out there can give you a profile, can identify the organism. Very few are able to differentiate between a bacterial versus a non-bacterial infection. So you could say, yes, the person is infected, there's an infection, but you can't say, using these tools, it's bacterial versus viral, for example, or it's a resistant bacteria versus a bacteria which is not yet resistant. So there's room for improvement there. the other thing is that there's loads of things in development on this in this chart, but not a lot on the market. Now, cost is the one one factor. It costs a lot, therefore your management don't want to spend that cost if they're not going to get anything out of it, but they don't know what they're going to get because we don't have the data. And until we get the data into the hands of clinicians, I mean, the tools into the hands of clinicians who can start using it every day, it's really hard to develop data. And so it's a little bit of a difficult situation, which we're going to have to come up with creative ways around, and data tech has possibility to help that. So I'm just going to move on quickly onto the non-genomic tools. These are perhaps what people will be more familiar with, so the multi-TOF, the mass specs, the flow cytometry, the use of clinical data, plus electronic health records. So again, there's a lot of stuff here in development, maybe a little bit more on the market, but the stuff that's on the market is your big equipment, the multi-TOF mass specs, mass spectrometers, and such like the spectroscopies. And, you know, that just, it's not available everywhere. And that's not just in some places across the board where it's just not feasible to have a Bruker machine sitting in your doctor's consulting room. So again, massive need for point of care, easy to use, rapid diagnostics. And again, data technology, I think, has a very big a role to play in this. In terms of treatment, that which we found in our review was that there are four areas, four outcomes really that people are using data technology. And the first one Maarten has mentioned is development of new antimicrobials. So taking things like machine learning and deep learning to screen millions of compounds to identify which features might be useful to come with or may not be toxic, or will allow the body to take up a particular compound better than it would otherwise have or has up until now. So to figure out how can we design new antimicrobials with a library of, as I say, hundreds of thousands or millions of compounds, which we don't know how they work, or we don't know that they work. That would be a really hard thing to do for people without number crunching power and without high-tech data. There was a new antibiotic in 2020, February 2020. MIT used machine learning to come up with a new antibiotic, which was effective in the lab and in mice against E. coli. They called it Halicin. And that's now gone on to be tested further. Mathematical modeling has been used to get chemical derivatives of macrolide antibiotics. So there's definitely scope to use this for developing new therapeutics. Moving on from that, in order to see what compounds can you combine to give a stronger output and to prevent development of resistance. And so machine learning is great in terms of, has potential to be able to show which compounds should go together effectively and how effective will they be. Also for developing antimicrobial peptides, so sequences of amino acids that can counter resistance and get rid of infection without generating further resistance. And then finally, looking at ways of facilitating treatment adherence and monitoring patients' intake of medicines, or just monitoring their health on a day-to-day basis. So the Cystic Fibrosis Foundation, Trust in the UK, for example, partnered with Microsoft in a project called Breathe. And they take, they're years into this project now, every day the patients note their vital signs, their respiratory values, and they've plotted their health on a daily basis, as I say, for years, and have kept a lot of people out of hospital as a result of respiratory infections, bacterial respiratory infections. So, and now CF Trust is now looking at what other diseases they can use this for. So moving on swiftly, because I know I'm getting to the end here. As I said earlier, these are great, but if you can't actually implement any of them, then that becomes an issue. So the challenges that became evident when we looked at the literature relate to data. How do you collect the data? How do you share the data? And how do you allow machines, systems to talk to each other? So it's how, for example, do you get around proprietary information? How do you get around regulatory requirements about data privacy? I mean, even if your patient gives you consent, your regulators may say you may not share this data in this geography, in this region. So it's finding ways of sharing data that are acceptable to everybody who needs to use the data. So federated learning, could be an option forward, where you've got a centrally trusted server where people can input their data, which has been analyzed already, so you don't have to put raw data there. And then you can build up the available databases from there. Data exchange, where interoperability, this links back to what Maarten said. Having systems talking to each other is fundamental, and until we can sort that out, it's really difficult to share data, to share systems widely. So the GLASS initiative may help us. Global Antimicrobial Resistance and Use Surveillance System is a step in the right direction. We'll have to see where that goes and how that can be expanded. I know there's about 106 countries which have now signed up to it, but there remains work to do to see how we can put that to good use. So that was the end of our first paper. We then realized that actually we had a core set of data which could actually be used fairly immediately, which relates to how do you share genotypic, phenotypic data from bacterial genomes, not human data sharing, but bacterial. And potentially that, if we could pull some guidelines together, that would allow people to, it would give a concrete tool that people could start using right now. And so keep your eyes open for a paper which will expand on this a little bit in the near future, looking at things like how do we make systems talk to each other? How do we do large scale analyses? How do we get a better understanding of mechanism of action? How do we track emergence and spread of outbreaks? How do we predict microbial susceptibility so that we can get better diagnostics? So things like looking at how data is formatted, whether that data is actual raw data, whether it's metadata, whether it's genomic data. How do we make processes as transparent as possible so that other people can reproduce those processes and we can move our knowledge of resistance mechanisms on? And how do we share data as much as possible? Obviously, there are realities where you can't share all data. So if that's because you may not from a regulatory perspective or because there's commercial limitations, you take that into account. But how do we find ways of sharing data as much as possible so that we can all benefit? And so that is what we've done for the last year and a bit. And so just as a final thought, I mean, we're really excited about the two papers that we've been able to put together with the data that we got out of the literature review. AMR is everybody's problem and everybody's responsibility. But the thing, I guess, about for those of us who work in AMR is that this is a huge opportunity to work together so that we can take this field forward. And I think, at least my feeling is that if we can at least use some of the information from either of these two papers to move the field of AMR on, managing AMR on, using data technology, then that idea, that kernel of an idea that started on the 24th of June last year at ADTCA will have been a success. So thank you so much for your time and interest. And that's all I have to say. And I'm happy to take questions. And I think I'm going to stop sharing my screen about now.
Wow. Thank you so much, Heather, for that really very well prepared. I think you really did a lot of, you really took a lot of time preparing this for us. And I really appreciate, sharing this with us. And it's really a good way to start off, because I think this is now the future. Guys, as we usually do, please feel free to share your question. You can either share it in the chat or, raise your hand as we usually do. As maybe we are waiting for some questions for Maarten and Heather. I like to maybe also ask one question, but mine is not really a very direct question. But I think looking at it, it brings out the need for multidisciplinary engagement, where you have even those people, scientists, maybe medical professionals, then collaborating with people who are very well versed with different data technologies. So how do you feel we can promote this right from a very early level, especially pre-service training, so that at least able to build such structures or such mechanisms, so that even in future when maybe students transition to professionals, it's very easy for them to appreciate the role that different professionals play. And in this context, the issues of data science and the different maybe technologies, and also trying to see how we can also bring social science into convergence as you're also looking at technology. Thank you.
Yeah. Maarten, I don't know if you want to answer that, and then I'll pick up after.
You may start, Heather. Yeah,
thank you. Okay, so thank you. That's a great question, Daniel. From my perspective, I think my experience has been that if you can get people from different disciplines in on the same discussion from very early, as you suggest, then you can get them thinking along the same lines. So if that is bringing in people who are doing computer science together with your life sciences, with your medics come, therapists come, life sciences people in a joint project, then that could certainly get them thinking along the same lines. So why I'm saying that is because so at Dundee University, where I'm doing my PhD, I'm part of the computing department, and they do, in the past as well, they've also done some really practical assignments where the computing students have worked together with students from other departments. And so I guess maybe that kind of thing, that kind of joint assignment could potentially facilitate joint working, or along the lines of, for example, in a past life, I was a speech and language therapist. And so what we found worked really well as undergrads is to bring all your therapists together and have classes together. So whether that would be your physiotherapist, occupational therapist, speech therapists, nurses, medics, all in a single class, and then working together on projects which are relevant to what they're going to be doing, because they're all going to be working in a community hospital, for example. That's actually had really good results for when they got out into a working environment. Now, I don't know how one engineers that in universities, but potentially that might be something that could be done.
Yeah. I think an addition what we are saying is, first of all, I like the 10 points in the follow-up publication, which helps, I think, to streamline the use of data technologies at the local, at the national, at the international level. I think to people also not to reinvent the wheel, but to look for existing solutions, existing ways of working. And I also want to mention as an example the organization CEDRIC, which is set up by the Wellcome Trust. And they do a lot of data technologies and surveillance. And I'm sure they will have also found their way. And so I would say, well, then connect to these people, adopt the same ways of thinking and working in order to avoid, a big mess, so to say. Yeah.
Indeed.
Good question, Daniel. Yeah.
Thank you. Thanks so much. I don't know whether we have anyone else with a question. I think people are still digesting the presentation, but I really want to thank you. I think you both shared your contacts, and I request if you can also share your presentation, maybe that people, as they also watch the recording, they're able to also appreciate the presentation. So thanks so much for joining us today. It has really been a great session, and I would like to challenge us in the call. There's a lot of richness among our meets if we bring on board our different expertises together. And such works can't be done in silos. It's only if we collaborate and be ready to learn from each other. That's how we're able to achieve this in a very impactful way. So thanks so much. This juncture, I'd like to hand over to you, Maarten, and then Heather for maybe some final remarks as we wind up. Thank you.
You mean some final remarks?
Yes.
Okay, well, first of all, I repeat what I said in the beginning. I want to compliment SAS Africa for their very impressive amount of work they have done for setting up the organization, for inspiring people around the globe, especially young people, not only in Africa, but also to set up programs and to set up teaching modules like this one, webinars. I do realize this is all in addition to your normal study obligations, and so I think that's really great. And I also wanted to mention that, as Daniel knows, AMR Insights has been thinking about developing a sort of umbrella organization where different students organizations can be connected. And if anyone would like to know more about that initiative, then he or she is most welcome to contact me. And I look very much forward to working with you, Daniel, but also with SAS Africa and also with other students around the globe, because students is the future.
Indeed.
Thank you so much. What do you, Heather?
Indeed. So yes, I'd like to echo Maarten's congratulations. It's I think what you guys are doing is a fantastic initiative, and just engaging people who have got so much to give from now and going on to the future. And the thing that excites me is coming from Africa. I am South African, so coming from Africa, just the wealth of different ways of looking at things and original thinking about how to solve problems that are relevant for your specific context, and often in a really simple way. So, I think that you guys are tapping into that. You're taking information from a variety of places, and you're running with the idea of how are we going to solve this problem together, and that's an amazing work that you're doing. So good luck, and thank you so much again for the opportunity to join you.
Thanks so much, Maarten and Heather. Maybe Anastasia, as you can just finish us off. Anastasia is my co-coordinator for the program, so she's been in the background. Over to you, Anastasia.
Thank you very much, Daniel, and thank you very much, first of all, to Heather and Maarten for sparing your time and coming to share with us your findings, and also being an inspiration in this fight against the AMR. To the ambassadors, thank you very much for your time. And yes, that's it for me. I apologize, I haven't shared my video. I do get a lot of network challenges, but that's me in the profile picture. So thank you very much, everyone. Probably back to you, Daniel.
So thank you so much, everyone, and I wish us a wonderful evening. I hope this is also a good start off to also collaborate more. And as Maarten said, there's some work in progress on how to have like an umbrella young ambassadors network, which is really important. And we've shared the link. I'll also share the link with us again for us to subscribe to the newsletter. Very insightful information is shared through the AMR Insights network, and also to enroll as an ambassador. So thank you, everyone, and have a wonderful evening. Bye-bye.
Thank you, Daniel. Have a good evening too. Thanks. Bye-bye.
Bye.